Okay, which most effectively uses data from the table. So we've got a quantitative command of evidence question with sort of a complete the text type question prompt. So let's read the prompt. Let's read the paragraph. To make sure they got the nutrition they needed while in space, the astronauts of NASA's Gemini missions were given menus for 3 meals a day, meals A, B, and C, on a 4-day rotating schedule. Looking at the sample of food items from these menus, a student notes that on day 1, the menu included sugar cookies or meal B. It's one of those two things. So, shrimp cocktail for meal B. No, that's not correct to the graph. So we're always checking for accuracy and relevancy. Hot cocoa for meal C. Well, that's not accurate to the graph either. Sugar cookie cubes for meal B. That's exactly it. That's accurate to the graph, and that is day 1, so it's relevant to the question they're asking. D, chicken and vegetables for meal A. That's, again, not even accurate, let alone relevant. Okay, we need to illustrate the claim with a quote. So this is a command of evidence, quotation illustration. O Pioneers in a 1913 novel. In the novel, Cather portrays Alexandra Bergson as having a deep emotional connection to her surroundings. Okay, so that's what we need to find. That's the claim, a deep emotional connection. She had never known before how much the country meant to her. Okay, that's starting off pretty well. The chirping of the insects down in the long grass had been like the sweetest music. She had felt as if her heart were hiding down there. Heart indicates emotional connection. Somewhere in the quail and the plover, all the little wild things that crooned or buzzed in the sun. Under the long, shaggy rides, she felt the future stirring. That definitely shows a deep emotional connection to nature. So I'm going to check that for now. Let's just read B, C, and D. Alexandra talked to the men about their crops and the women about their poultry. She spent a whole day with one young farmer, away at school, No, this is not a deep emotional connection. Alexandra drove off alone. The rattle of her wagon was lost in the howling wind, but her lantern, held firmly between her feet, made a moving point. No, this is not a deep emotional connection with your surroundings, your nature or natural surroundings. D, it was Alexandra who read the papers and followed the markets. Whoa, that's the opposite. That's not it. A is the correct answer. To you. So what is this? To you, we need to illustrate the claim with a quote. So the command of evidence illustrates with a quote. To You is an 1856 poem by Walt Whitman. In the poem, Whitman suggests that readers whom he addresses directly have not fully understood themselves. So we need to capture this idea. You have not known what you are. Well, that's a pretty good start. You have slumbered upon yourself all your life. Your eyelids have been the same as closed most of the time. That looks pretty good. That's telling people or whoever he's talking to, you don't really understand yourself. Let's just check B, C, and D. These immense meadows, these interminable rivers, you are immense. No, that's not it. I should have made my way straight to you long ago. I should have blabbed nothing but you. I should have chanted. Well, no, that's someone who's in love or something. That's not. You don't know yourself. I will leave all and come and make the hymns of you. None has understood you, but I understand you. So this is really not saying, this is the only other one with the understand concept in it, but it says he, whoever's writing, or she, does not understand you. It's not about you not understanding yourself. So this is not the right idea. A is the correct answer. Okay, if true, would support Armijos' hypothesis. So we've got to find the hypothesis, and we want to figure out which claim below, if true, is supportive of that. So roasted green chilies are a popular ingredient in southwestern cuisine. But the traditional roasting method of burning propane is not environmentally friendly. To see if solar power could provide a better alternative, engineer Amijo and his team roasted batches of green chilies using between 38 and 42 heliostats, which are devices that concentrate sunlight. The team was successful in reaching the same roasting temperature used in the traditional propane resting. Okay, so they used the sun to heat and roast the chilies. There's my picture of a chili. That's terrible. But anyway, the team was successful in reaching the propane roasting, but they found that propane yielded faster results. So this is slower. That's the idea. While the fastest solar roasted green chilies took 6 minutes, batches using propane only 4. Armijo hypothesized they can reduce the roasting time for solar roasted green chilies by using more heliostats. If they pump up the heliostats, they'll pump up the chili time, more chili speed, if they have more heliostats, or more suns maybe, right? But that's the idea. So what would support that? The temperature inside the roasting drum is distributed more evenly when roasting green chilies with solar power than with propane. No, it's not about the distribution. We want to see the fact that the number of heliostats corresponds to the speed of the chili roasting. Attempts to roast green chilies using 50 heliostats yields results in fewer than 6 minutes. So more heliostats, shorter time. That would be a supportive evidence. That's probably our answer. I'm going to circle that. Let's just check C and D. Green chili. No, we didn't differentiate green chili. Okay. It didn't say chile verde up above. Connoisseurs prefer the flavor salt. No, it's not who prefers what. Again, that's not right. The skins of solar roast. No, again, it's not about the skins. And again, did they mention green chili? Oh, they did actually. Take that back. They do mention green chili up above. I missed that. Okay. So, but it's still not what they prefer. And it's not whether they're easier to peel or not. So these C and D are irrelevant to the question itself. B is the correct answer. Okay, I've got a graph, so I have a quantitative command of evidence question here. We want to find the most effective uses, which choice most effectively uses data from the graph to complete the example. So we have to complete the example. So let's go ahead and read. Electric companies that use wind turbines rely on weather forecasts to predict the amount of power in megawatts that they can generate using wind, so they can determine how much they'll need to generate for other sources. When winds are stronger than they were forecast to be, however, the predicted maximum amount of electricity wind turbines could generate will be too low. So strong winds would think it'd be higher energy, but their maximum amount, their predicted maximum amount is too low, right? It comes in not as expected. For example, the graph shows that the west region, the winds were, let's see what this graph is. So the amount of additional energy wind turbines could generate when winds were stronger, as we see in the west, that is less than in the Midwest. So the amount of additional energy turbine generators could generate when winds are stronger. So what's the idea here that we need to finish? They use the wind turbines to rely on forecasts. Okay. They need to figure out how much from other sources, but winds are stronger. The predicted max of electricity from wind turbines could generate will be too low. So they predict too low. For example, the graph shows that the west region, the winds were strong enough to generate about 150,000 more megawatts of electricity. So that's not showing too low or not. The absolute level doesn't seem to me of any significance here. So weak that the electricity from wind turbines was about 155,000 megawatts less than predicted. So wait, the amount of additional electricity wind turbines could generate when winds were stronger. Okay, so this, all right, so I didn't think I understood the graph, so we've got to understand the graph. This is this is the differential of what they could, in theory, do, right? This is the gap. So they, in theory, could add 150 more, 175 more. So the fact that these are both positive just simply means they could generate more, okay? And that's what proves the point here. So let's go back and read A again. Strong enough to generate about 150,000 more megawatts of electricity. So is that true for the West? Yes, that is accurate to the graph. Is it relevant to our example? Yes, it is actually. So let's take that away. That's a very possible answer. So weak that the electricity from wind turbines so again, this is the winds were so weak the electricity from wind turbines was about 175,000 less than predicted. No, that's not it. Not about the winds being weak. So weak, the winds were not so weak. That's not right, okay? The winds were strong enough to generate 175,000 more from wind turbines. Well, no, that's not right, because that's not clear. From what wind turbines? Only in the Midwest, right? But this doesn't say Midwest, so that's not exactly accurate to the graph. The graph shows 150 in the West and over 175 in the Midwest. So that's not right. A will be our correct answer. The table shows data, so we have a command of evidence question, which shows use data from the table to complete the claim. Okay, this is quantitative. I need to finish the claim here. Let's read the text. The table shows data from the paleontologist such and such 2021 study of 2 sets of dinosaur tracks preserved in a fossilized lake in Spain. The tracks referred to as La Torre 6A and 6B were left by 2 individual theropods, dinosaurs that walked on 2 legs. The team's findings suggest that of the 2 theropods, the one that left the La Torre B tracks had a higher maximum mean speed. Okay, so why would they include that? The estimated footprint length, so the size of the foot, I don't think that's going to be critical. Average stride length, that definitely could be important. Estimated mean speed, well, okay, the estimated mean speed, that's directly what we want. So it had a higher maximum mean speed. So this is the mean speed. We want to know the higher maximum mean speed. So what do we know? The stride length for this one is higher, and its estimated mean speed is higher. So the maximum, it actually gives a range. So the maximum is 12.4. The maximum here is 10.3. So the maximum mean speed is 12.4 versus 10.3. That's the data we want to prove our point. So a longer footprint, not important. A longer footprint, no, not important. A shorter footprint, well, I don't see why the footprint length is important, but it is associated with a shorter footprint. So a shorter footprint and a longer average stride length. Okay, yeah, the higher answer is definitely this one, and it is associated with a higher stride length, 5.57 to 5.23, and a shorter footprint. So for whatever reason, that correlates to the data, which is a higher 12.4 mean speed for 6B. Okay, so that would be a shorter footprint and a shorter average stride. No, that's not right. It's inaccurate to the graph, so that's not correct. C is the answer.